For decades, scientists and engineers have been trying to crack the code on this kind of swarm intelligence to create robots that can work together like that, for search and rescue, fighting wildfires, you name it. But here's the problem. It's been incredibly hard. How do you control thousands of robots without a central leader telling them what to do? You can't have one joystick for 1,000 drones. They need to self-organize, and until now, our synthetic swarms have been clunky, inefficient, and nowhere near as agile as their biological counterparts. But that might have just changed. A breakthrough new framework is taking a page straight out of physics class to finally make decentralized robot swarms a reality. The key challenge, as researchers pointed out, is that decentralized control mechanism. Birds and bees do it perfectly. Our robots? Not so much. So how did they solve it? They went back to geometry and fundamental mechanics. The team introduced a brand new concept called curvature. Think of it like an intrinsic charge. Like a proton has a positive charge and an electron has a negative one. Each robot in a swarm is assigned a positive or negative curvature value. This value dictates how that robot will react when it encounters another robot and an external force. It essentially tells the robot how to curve its path. This simple, charge-like quality is the seed for incredibly complex group behavior. And the crazy part is how well it works. This curvature, this little rule of how to turn, directly drives whether the entire swarm decides to flock together, flow in a stream, or cluster into a group. In experiments, they showed that this rule controls attraction between robot pairs, and most importantly, it scales naturally. The same simple rule that works for two robots can seamlessly govern the movement of thousands. And this isn't just about programming. This is a fundamental mechanical property. It means the challenge of swarm control shifts from writing millions of lines of complex code to a problem of material. Science and design. You can literally build this curvature property into the robot's physical structure. This opens up a world of possibilities, from massive delivery drones coordinating in a city skyline, to microscopic medical robots swimming through your bloodstream to deliver drugs exactly where they're needed. This is part of a bigger wave of innovation in swarm robotics. Just recently, we've seen patents for using robotic swarms in aerospace manufacturing, and other engineers creating tiny bots that self-assemble into complex structures using simple math. But this curvature approach feels different. It feels elegant. It's one of those solutions that seems obvious in hindsight. Of course, nature would use simple physical rules rather than complex central processing. This isn't just an incremental step. It's a fundamental shift in how we think about controlling collective behavior. It's bringing us closer than ever to having a robotic ballet in the sky, all thanks to a little thing called curvature. So what do you think? Search and rescue robo-swarms or medical nanobots? Which application are you most excited about? Let me know down in the comments.